on to assignment number 20, which is, well, let's just get started on it. It's something brand new, so something you haven't learned anything even remotely about before. And to motivate it, I wanted to talk a little bit about the distributive property and making sure that you're keeping track of all the things that you're multiplying. So we're familiar with this. This was 3 times 4 plus 2, and the first way of doing it would be in the order of operations. According to order of operations, you would do 4 plus 2 to make 6, and then you would multiply that times 3, and your answer should be 18. All right, so the final answer that we get is 3 times 6 to get 18. But then when we talked about the distributive property, we found out that there was another way of doing that. You don't have to add first and then multiply. You could multiply first, 3 times 4, as well as 3 times 2. You could multiply first and then add, so 3 times 4, and then add 3 times 2, so long as you remembered by drawing these arrows that you multiplied both things. And this was called the distributive property. And the reason why it was called the distributive property is because you had to distribute the 3 to both things in order to get it right. So let's see what I mean. 3 times 4 is 12, plus 3 times 2 is 6, which does give me 18. So I got the same thing as when I did 4 plus 2 to make 6 times 3, so long as I multiplied them both. So the only mistake you could make when you're distributing is if you forget to pass out the 3 to everything. If I just did 3 times 4 and not 3 times 2, then I wouldn't get the answer right. Okay, so this I would just get 2 and I wouldn't get 18. So in other words, again, when you're distributing, the thing that's difficult is to make sure that you pass out the 3 to both terms, and we drew an arrow or a rainbow to guarantee that you remembered 3 times 4 as well as 3 times 2 for the distributive property. But then what if you have something even more complicated like this, the 3 plus 1 times 4 plus 2? So if we're doing order of operations, it's just as easy. So that's 4 plus 2 to make 6. And then 3 plus 1 to make 4, and then you're timesing those things so that your answer should be 24. But what if I wanted to distribute? What am I distributing exactly? So we need to keep track of all the stuff you're distributing, because I'm distributing from the 3 to the 4, from the 3 to the 2, and then I'm also distributing from the 1 to the 4 and from the 1 to the 2. And this difficulty of keeping track of the 1, 2, 3, 4 things you have to distribute, all the 4 things that are multiplying each other, the difficulty of keeping track all of those 4 things has led to many different methods of solving this kind of a distributive problem. But the method that we're going to use in this class is called the box method. So here is the box method. I'm going to put the 3, I'm going to use a square to keep track of all the 4 things that are multiplying. 3 multiply 4 and 3 times 2 are going to go here, and 1 times 4 and 1 times 2 are going to go here. So here's what it looks like. I put 3 and plus 1 on the top of the box. In other words, this is the length of the box. So I put it on the top. And then the second term expression, I'm going to put 4 and plus 2 going down the side of the box. In other words, that's the width. And now I can use the box to keep track of all the things that are multiplying. 3 times 4 is multiplying to make 12. So inside the box I put, so it's just like a times table. 3 times 4 makes 12. 1 on top times 4 on the side. 1 times 4 goes here. And that's 1 times 4 is 4. Oh no, using the highlighter. And then next one. And so the way the box method works is that you're just using the box to keep track of all the stuff that times these times, and then these times, 1 and 4, and now these times, 3 and 2. So 3 times 2 is 6, and then the last one is 1 and 2 times to make 1 times 2 is 2. And then the last step of the box method is to add all these terms together. So 12 plus 4 plus 6 plus 2. Well, let's see what that is. 12 plus 4 is 16. 16 plus 6 gives me 22, and 22 plus 4 does give me 24. All right, so long as everything multiplies everything else, you can distribute this. And we're going to have probably 2 videos on this because I'm going to take my time just practicing all of these. It's easy, but you just have to be super organized about it. So we're going to have a lot of practice. But let's define our terms here. A couple of terms that we need to define. One is the word binomial. Binomial. And exponential expression with 2 terms. So we defined terms last time, and so an example of a binomial, let's see, x squared plus x to the 4th minus 6x plus 2, 3x minus 1. Which of one of these has 2 terms? Let's count. This has 1, 2 terms, so yes, this is a binomial. This has 1, 2 terms, so this is a binomial. But this has 1, 2, 3 terms, so this is not a binomial. A binomial has 2 terms. All right, so this one and this one are an example of a binomial. And in this assignment, we're multiplying binomials, so we're multiplying things that have 2 terms. And then we're going to be using, the method for this is the box method, a way to keep track of all the things that multiply each other when in the product of 2 binomials. And I could probably do a little bit better than that. Instead of all the things that multiply, I could be precise about how many things you multiply. There are 1, 2, 3, 4 parts of this box of the 4 things. Not all the things, but the 4 things that multiply each other when you make the product of 2 binomials. The word product here means multiply. In other words, the box method, we're going to be multiplying 2 binomials. Like, for example, these don't count as binomials, but let's call them binomials. And when you have 2 binomials, 3 plus 1, and then 4 plus 2, you put, in the box method, you put them on the top and the side of the box, and then the box keeps track of the 1, 2, 3, 4 different things that multiply each other. All right, so let's start practicing. All right, a lot of words there, so I'm only going to do these 2 examples, I think, on this video. So box method first. Notice that I'm trying to multiply these 2 binomials. If I wanted to, I could times negative 2x times x, negative 2x times 1, and then 10 times x and 10 times 1. So it's perfectly okay so long as you multiply everything by everything else. But I'm going to use the box to keep track of that. So there's a box with 2 sides going this way, because that's a binomial. In other words, there's space for 2 on top and there's space for 2 on the bottom. This term goes on the top, negative 2x and plus 10, and then the other term goes on the side, x and plus 1. And now you multiply the top times the side. So that's negative 2x times x. And I'm going to write out what I'm multiplying first. You don't need to write it out because I'm eventually going to erase what I write here. But negative 2x times x, and then this is 10 times x, and this is negative 2x times 1, and then this is 10 times 1. All right, so all I did here was multiply the top times the side. And now, normally I would figure these out as I go, but negative 2x times x times x is x squared. So this is negative 2x to the 2nd power. Why? Because negative 2x times x is, I've got 1x here and 1x here, and the rule of exponents says to add. Negative 2x to the 1 plus 1 is 2. So that's the total number of x's on the top and the side is 2. So that's negative 2x squared. And then this is just fine as it is. So that's 10 times x is 10x, and then negative 2 times 1 is just negative 2x. And then this last one is 10 times 1, which is just 10. You're welcome. And then, okay, here comes the last step. Now, I could write this out. Negative 2x squared plus 10x minus 2x plus 10. I've written all of the terms out now horizontally so that I can observe which are the like terms. So this is x squared, this is x, and this is 10. Now, the two in the middle are the two like terms. But it just so happens when you do the box method that the two like terms are always on the diagonal. So I draw an arrow going up this way to emphasize that I'm adding the 10x and the minus 2x, these two terms here. And of course 10x's minus 2x's, 10x minus 2x gives me 8x's. So these two terms here give me 8x's. Alright, so altogether I could replace these with plus 8x. And then let me clean the plus 10 up a little bit, plus 10. Alright, so the problem wanted me to multiply the two binomials, and I wound up with negative 2x squared plus 8x plus 10 was the final answer. Once you start getting used to the organization, I'm going to go just slightly faster this time, and hopefully you should start to make more and more sense. So I think it's going to be better if I actually draw real boxes here. Okay, and oops. So I'm going to put the first binomial on the top of the box, negative 6x and plus 1, and then the second binomial goes on the side of the box, 9x and minus 10. That is negative 10 right there, and I'm going to make sure I keep the negative with the 10. And now I multiply inside the box. Negative 6 times 9 gives me negative 54. X to the, I've got 1 here and 1 here is 2, x to the second power. Next one is 1 times 9x is 9x. Negative 6 times negative 10 is positive 60x. And 1 times negative 10 is negative 10. And then I can, on the diagonal, recognize that I have here positive 9x's and positive 60x's for a total of 69x's. So those two terms add together to make the 69x's, and then here's minus 54x squared, and then here's minus 10. Notice that they all have different ranks, so I can't add them together. And my final answer is negative 54x squared. That came from multiplying here and here. And then plus 69x's, and that came from a mixture of things. It came from 1 times 9 plus 6 times 10. In other words, 9 plus 60. And then the last term came from the 1 times the negative 10, the 1 times the negative 10, and that's negative to minus 10. And I've got 3 terms in my final answer, and that is that. So don't worry, we're going to practice a whole bunch of these. This is the assignment multiplying binomials. You are multiplying this group of two things times this group of two things using the box method.